Hello YouTubers. Okay, it's not going to be a very long video, but maybe it will. I tend to ramble, so we'll see. One thing I wanted to do here today was say a couple things about, I see a lot of people repeating the same experiments that have been, I guess you'd call them time-honored experiments, like Stirling engines and steam engines, the Joule thief, passive solar heaters, passive solar water heaters. You know, those things have been around a long time. And you guys do some great work out there on that stuff. You know, stoves, air conditioners, all different kinds of applications. But I wanted to take a little time to turn you guys on to a few things that I wish more of you guys out there at YouTube would get involved with, because some of these new things really stand to change a lot of the way we do things in the world and to our benefit. One of the first things I wanted to mention would be carbon nanotubes. Now, carbon nanotubes are made from burning carbon with an electrical arc with a gas present, with all over the air pulled in a vacuum, put a gas in, burn carbon in an electrical arc. It makes single-walled carbon nanotubes. And what does that mean and why do we care? Well, single-walled carbon nanotubes, when added to lithium batteries, makes the energy density 10 times, which means that you can replace one car battery or 10 car batteries with one car battery. So think about what that means for electrical car. And that's already being done and pretty deep. Now the carbon nanotube batteries just straight out, you can take carbon nanotubes and put them in ink and actually print paper batteries. I think Stanford University did it all the way back in 2009. And it's a simple, easy, cheap process. Carbon nanotubes are available on the internet. They're not toxic. You can order them and you can mess with them. So I need some of you guys out there that are sharp, get busy with some of these carbon nanotubes, right? There's too many corporate people working on it and hiding it from us, and not enough guys out here on YouTube divulging it to the population so we can use it. Now, carbon nanotubes not only can be printed on paper, right? You can just put it in ink and print on paper carbon nanotubes. You can put it into a solution and spray on and have a spray-on battery. And the energy density is quite remarkable. And the recharge, the life cycles on it is the millions. Okay, so a few thousand times life cycle on a battery that we're building today versus a million times life cycle. So it's, you know, a lifetime battery. In addition, you can print it on a piece of paper, roll it up like a capacitor, and you can charge it like a capacitor. The charge times can be just nothing. So I asked the question, well, why aren't these carbon nanotubes out if Stanford University did this simple process in 2009? Well, what I discovered in there, I started looking for them. I want to buy one. I want to experiment. I want to take it apart. Well, I found out that a lot of the automobile companies, a lot of the petroleum companies have bought up all of the battery manufacturers, the big names like Energizer, Duracell, and those things. And they absolutely just prohibit it because it will do away overnight. It will do away with the gasoline automobile, okay? Because you're talking about being able to print a 12-volt battery on a single piece of notebook paper that has 2 amp hours. And that's not even the most you can get on a piece of paper, okay? It's just give you an idea, but can you imagine batteries made out of paper in a car that would have a range of 3,000 to 4,000 miles and a recharge time short enough where you could stop at a gas station, go in and take a leak, and by the time you got back out, your car's recharged. I mean, wow, you know. And that's not even getting into how it's going to change motors and a lot of other electronics, right? It's just trying to push you guys, and I want to see, and if you watch this video and you do some carbon nanotube experiments, please send them to me. I'll watch them. If nobody logs or gives you a thumbs up or likes your videos, I'm going to be watching and paying attention, and I'm going to be showing some of my own carbon nanotube work in the future. not only is it, so think of how to change solar, think of how to change automobiles, think how to change your cell phone. They even say it'll change how you get energy at your house, that you'll have a box at your house the size of an air conditioner sitting out in your yard, and you'll only get on the grid once a month to download enough energy to store to run all month in that box, right? And so it'll smooth out power distribution and kind of help our system we've got it set up for delivering power and eliminate power shortages. And then it's going to do a lot of things in motors and a lot of other things. So carbon nanotubes, guys, check on it, get busy. I want to see some YouTube videos out there of some carbon nanotubes of some guys like us. There's just nobody doing it. One of the other things I wanted to say was these clear solar cells that they're coming out with. Transparent glass with solar capabilities on it. There's a company called Blue Glass in Australia. Done some really amazing work. Now, we're talking about transparent windows being able to deliver solar power. Well, imagine every window in your house is transparent, or even a big bay window in your house, a solar panel. And then think about skyscrapers. Then think about cars. Think about cars with windows. Think about cars with glass roofs, right? So if you had solar panels on all the glass on a car and carbon nanotube batteries, well, that changes things a bit, doesn't it? Well, here's the kicker about these clear solar panels. And again, these are not terribly complicated applications. They're closely guarded secrets, but they're not complicated. Now, the kicker about the clear solar panels is this, is they use a broader spectrum of light to get power from the sun. Meaning that they use a broader spectrum of light to get power from the sun. They're over 50% efficient. Modern solar cells are only 15, 16, 17% efficient. We're talking over 50% because it's using ultraviolet light. So imagine your window in your house. It's big, about the same size as a 100-watt solar panel, right? And now if it was clear and it had 2.5 times that amount of power. So now a small 5-watt panel that's, this big is all of a sudden now a 15-watt panel, and a 100-watt panel is all of a sudden a 250-watt panel. So, and it's completely transparent. So you guys need to check on this stuff and get some of these things and start working on them. And again, I'm going to be showing some of the stuff I'm going to be putting together on that. And now they have a spray-on application. Those elements can be put into a solution and actually sprayed on clear glass and make clear glass a solar panel. And lastly, I wanted to tell you guys about heat reclamation, because I don't see enough of you guys working on heat reclamation. Gaining waste heat that we throw away. I'm going to give you a brief analysis of a window air conditioner. This represents 5,000-watt window air conditioner. I'm sorry, 5,000 BTU window air conditioner. This would be a 110 that you can plug in, put in your unit at the house. It's rated at 5,000 BTUs. What you have inside of an air conditioner is you got a motor and it's got a fan on both sides. It's one shaft and the blades are pitched opposite ways, so it blows air both ways. Now, you got basically a heat exchanger here and a heat exchanger here and a compressor, right? You got the high side and the low side when you're in the gas and in the liquid. I'm not going to get into that, how it operates. What I want to tell you is that a window air conditioner that puts out 5,000 BTUs of cold air to the inside puts out 7,500 BTUs to the outside. So in actuality, it's really a better heater than it is an air conditioner. So if you think about those numbers and then realize that a lot of houses in America have up to 100,000 BTUs of air conditioner, right? So you need, and a good formula for that is basically with how we build houses, somewhere about 40 BTUs square foot is what you need to heat the old American wasteful house energy consumption requirements, yeah. So 100,000 BTUs, and if you look, this is about a 20% gain here, roughly. So if you add 20% to that, that's 120,000 BTUs, right? Well, your hot water heater uses anywhere, and I'm talking about 35 to 50 gallon, is 4,000 to 6,000 watts. Well, guess what? On the internet, there's a BTU to watts conversion. I'll leave it to you guys to look it up. But what I want to tell you is that your residential air conditioner throws away, pumps to the outside, 3 times the amount of energy that you need to heat your hot water. So you throw away 3 times this much energy and then buy it again to heat the hot water. It's craziness. It's ridiculous. Anywhere you've got a compressor, an evaporative coil and a condenser coil, it's this way, right? And the difference in an air conditioner and a heat pump is they switch these coils by valves. They don't actually move them, but there's valves inside of a heat pump that switch these coils. So you see that it's a better heater than it is an air conditioner. So if you switch these around with valves on the inside, in the wintertime it becomes a heater. Well, really, you can take your window air conditioner and turn it around backwards, put your control outside, turn it up on high, and it'd be a better heater than it is an air conditioner. That's just the truth of it. So there are lots of ways to capture these BTUs that we're throwing away from our refrigerator, we're throwing away from our HVAC units in our house, that we're throwing away from our freezers. Anywhere there's a condenser, compressor going on. Okay. One of the ways that you can do that is, I have ideas all the time. I think, aha, I've really got one good. And I come up with this idea how to recapture it. And I thought, well, all you have to do is put a coil in a barrel, your condenser coil in a barrel, and you reclaim that heat. Well, air and water, water's 9 times more dense than air. So instead of your compressor working so hard to dump that heat into air, I've had lots of videos out talking about how good of a thermal mass water is. So if you had that condenser setting into a bucket of water, imagine how much of that heat would be transferring through the water. It'll transfer so much heat through the water that the actual air conditioner will work easier, and the compressor will work easier. It's just easier for it, and it'll increase the efficiency of your air conditioner. So not only will it increase the efficiency of the air conditioner, but as well, it'll give you hot water, free hot water. I'm going to have some videos coming up on these subjects, but I wanted to give you mad scientists and backyard guys a little kick in the right direction. Again, you make any of these videos, please send them to me. I want to watch them, and I'm going to be coming out with some more videos in this area. Okay, you guys got any questions, any comments? Please leave them. Thanks for watching.